I'm Alex Berner. This is Basics with Berner. If you've seen the Binging with Babish channel, I stole this from him. This microphone is freaking me out a little bit.
That's good. It sounds great.
It sounds great? Okay. Feels really weird in my ears.
It's supposed to freak out.
Good. So last time we had this meetup, we had a couple great talks, but they were also really advanced. And so I wanted to do a talk that was more entry-level TypeScript. I have failed to send out a poll yet, but at some point I want to poll the whole meetup group and see where everyone's relative levels of TypeScript usage are. But this is more for you're getting started with TypeScript, or maybe there will be fun info for everybody. Today I want to talk about feedback. Today I want to talk about the danger of the any type and some alternatives you can use to avoid any. Any is a very tempting type because it makes all the compiler errors go away, but it also removes all type safety.
If this one were pointed directly at you.
Nice, okay. It also removes all type safety and basically brings you back to square zero. It's bad when you use any. You could do something like take an input value in a function and do input.value without knowing if it's null or not. And bam, you could get a type error, cannot read property value of null. It's also bad because you can assign things to the wrong types. If you have your input and you've said it's any, you can assign it to this words that you've declared as a string, and TypeScript will be like, yeah, that's fine. It's anything, so it can be a string. And then you can try to do words.split, but again, during runtime, you'll get a type error. It's also bad if you have no return type on the function, then the any can propagate. So here we are creating this value, but because we've returned a property of an any is still any. And so now this value is any, and you're spreading any all throughout your code base. But completely typing your code base can be a daunting task. So like here, we had like 400,000 lines of JavaScript and wanted to start using TypeScript and couldn't just flip a switch and instantly have great types for everything. So you know, there are some middle grounds. Perfect is the enemy of good. You shouldn't hold out for perfect types. There are a lot of fun compromises and alternatives you can use along the way, other than just throwing any's around. Alternative number one is type inference. TypeScript has really powerful type inference. A lot of times it can correctly identify the types of your variables without you needing to step in. There's a ton of primitive inference that happens, and whether you use let or const actually affects the kind of inference that happens. So here with these consts, you can see that the inference is more strict and narrow. This num5 is the type of 5. The string 5, this is supposed to have quotes around it. That's a mistake, but it's the exact type of the string. This boolean is a true, and this null is a null. If it's just a let, TypeScript understands that you can overwrite the values later, and it widens the types a little bit for you. And so now num is a number. You can assign any number to this variable. String is just a string. You can assign any string to it. This is a whole boolean. You can assign a boolean to it. The null turns into an any. I don't know why that happens, but that is what happens. Arrays and objects also have great inference. So here I just threw a bunch of values into this array, and TypeScript correctly looked at the type of each value and said, okay, this is an array of any of those 4 values. It'll also do it for an object. I threw some numbers, some strings, some booleans, some nulls into this object, and it correctly pulled all of those types out. Now, if I try to access a property on thing that's not one of these properties, it'll throw an error. I can't add new properties to thing, but it will correctly, like I can treat thing.1 as a number. And now, as of TypeScript 3.4, I can use const assertions to make the inference even more strict. This is getting a little more advanced now, but I'll pull it back. So here, this is the same array, but I put as-const at the end of it, and the array becomes a read-only array. I can no longer modify it, and instead of just a grab bag of those 4 types in any order, it becomes an exact tuple. So it has exactly 4 elements. Each of the types lines up with the element location. And similar with the object, this is that same object from before, but I put as-const at the end. And now all of the properties are read-only. I cannot mutate them later. And the types have become much more exact. So instead of number, it's a 1. Instead of a string, it's the string 2, true and null. Inference even works for some function arguments. TypeScript uses the context of the function, if it can. So here, I'm assigning a random function to the window.onMouseDown event. And TypeScript correctly infers that event is this mouse event object. Or if I have an array of numbers and I do a for each, the x is read as a number. TypeScript knows that x is a number. However, inference does not work without this context. So if I have a function that's just floating all alone that I define myself, the input will still be any. For things like top-level functions and public methods, it's important that you define your own argument types. I know it's hard, but you should do it. Because you're defining the API for your own code at that point. That's where anyone could come in and use that function or that method. So it's good to get the contract right, get those arguments down. A second alternative to any is the built-in types. TypeScript, through the tsconfig lib property, you can load in all sorts of fun built-in types, like for Node.js and the browser DOM. Like our input that we were using before actually has a built-in type from the DOM library for HTML input element. And then once we use that, if we're using VS Code, we can use input dot, and it will autocomplete all of the different properties for the HTML input element. And it makes developing way more fun. It's great. These are all standards that they're implementing and providing types for. So you can just check community documentation to find the kind of types you need. So a lot of the time, I'll check MDN to figure out which HTML entity I'm trying to dig up, like the text node is a weird one. Node.js has their own docs. MDN is just the best for all JS language types and the DOM built-in types. Alternative number 3 to any is the new unknown type. As of TypeScript 3.0, there's this new top-level unknown, and it's the most useful when your value comes from outside your control, like when you're reading from AJAX responses from API requests, the URL, local storage, cookies, JSON.parse results. Like you truly don't know for sure what the type of that value is at that point. And so when you have unknown, it's similar to any, where you're saying like, I'm not sure. But instead of any letting you do anything with it, unknown basically lets you do nothing with it until you've proven with runtime logic that some properties are true of the value. So here, input unknown, and I try to do input.value, and I get a compiler error. The object is of type unknown. I can't just do .value on it. But if I say input instance of HTML input element, and that passes, then TypeScript knows at runtime input is an HTML input element, and it will let me access the value property. And there are tons of fun built-in ways in JavaScript to prove, like there are ways in JavaScript to prove the type of something at runtime that TypeScript will pick up on and use as clues for type narrowing. So here, if we have this input, if we use instance of, we can say if this is an instance of the HTML input element class, TypeScript will narrow it down to the HTML input element. We can say if the type of input, this is another built-in, is string, TypeScript will narrow it down to a string. And if the input equals the string 5, TypeScript will narrow it down to the string 5. So these are all things where you don't have to worry about whether TypeScript's correct, because it has to occur at runtime. Like, if input is this string, it will make it into this if statement. TypeScript can follow that logic correctly. You can also build your own type guards. You can do this type narrowing yourself. So let's say you had an interface thing that had a property foo with a value bar, you can create a function that takes an unknown, and its return type is that val is thing. This is a special TypeScript keyword for creating your own typeguard functions. And so now we can actually do whatever we want in here. We could just return true. And if we called isThing and passed a value to it, TypeScript will trust that we know what we're doing inside our typeguard and will assume that that value is now thing interface type for the rest of the code execution. So you do have to be careful within your typeguard function. You want to be strict because you can shoot yourself in the foot. You can do whatever you want in here. Unfortunately, I ran out of time to make more slides past this. But I would want to go more into making your own typeguards. Why unknown objects are hard to type narrow. Here, if you look, so we're saying the type of value is object. So we've narrowed it down to an object. We say it's not null, because in JavaScript, an object can be the value null, and then you can't access any properties on it. We can say value.hasOwnProperty foo, but it's still, at this point, just an empty object, so we can't do value.foo equals bar. And so we have actually built our own hasProperty helper. It's a really small little function, and it lets you pass in an unknown value and then the name of a property, and it will type narrow that to an object with that property. You can also pass in a typeguard, and it will give you back an object with that property and the type of the property declared. But I want to go into that later, and also we have not open sourced it yet. So it's still locked away in our code base somewhere. And that's all I have for now.
Nice.
Any questions about any of this? Yeah.
Can we go back to the if logic to, here. So I just discovered that if you do this as a series of guards, so if you do like if not blah blah blah, TypeScript doesn't follow.
Well, what do you mean? Like if this was, if input is not instance of HTML input element?
Yeah. So like if you're, instead of like nesting your logic inside of the ifs, you go like if not and not input instance of, and then inside of that if statement you throw, and then you do your logic return input whatever, right? In your main function block, it doesn't catch that. So do you know when that's going to be fixed in TypeScript?
That's weird because we use that pattern a lot.
Yeah, I tried it and I was like, I got bit.
It is a problem with unknown specifically.
Oh, with
unknown.
Yeah?
Yeah.
Okay.
So unknown represents the set of all possible values that a variable can have.
Oh, okay.
Right?
Yeah.
And so when you say that it can't be this thing, you need a way to express that it can't be anything other than that thing. And describing that type isn't something the language is currently expressive enough to do.
Okay.
But if you were instead taking a type union,
Starts with.
Right, like if you started with number or string, and then you said if val not equals string, then that'll narrow just fine.
Okay. Interesting. Thank you.
Can you maybe next time or go over some TS-lint rules that you can filter out? You can say don't declare any, and also there's a type def section in TS-lint where you can say, hey, we want to define, make sure these things are defined.
That is a great idea. Yeah, I would love to do that. I'm our TS-lint guy here, and I absolutely love TS-lint. I actually added a custom TS-lint rule for assigned arrow functions to make sure that they have return types and archetypes. So yeah, I'll do a part 2.
Can typeguards be automatically generated?
What a great question. That's something that we've looked into a little bit, but haven't actually played with any of the options yet. So there's a lot of third-party libraries like IOTS and run. Well, there's QuickType. QuickType generates both the types and the type guards and does it for a lot of languages. It's very impressive. It uses JSON, and it does all of these, including TypeScript. And I have tried none of them, but there are a lot out there. Run types maybe is one of them? Run types.
TypeScript is another one.
TypeScript is? Oh my gosh. We're clearly going to need some research to figure out which of these is the best one.
All of these libraries are like, you ask which one of these is the best, right? And the core concept of all of these is that you want to inspect the type of an object or something at runtime. But TypeScript's type system is inherently doesn't exist at runtime, right? It's structural, and so it's just based on what members are there, because like if members are there and the code doesn't error, and then it checks out kind of normally usually. And running your code such that that is the case, and if you do provide everything with the right shape and that it works out, is like a really great way to develop JavaScript, because it means that you can just remove a component, drop in something that has the same interface, and everything checks out fine. When you start like wanting to inspect your types at runtime and do that kind of runtime inspection stuff, that's when these libraries come into play, because you're trying to do something reflective with the types.
Have you worked with any of these before, and do you have any favorites?
Not beyond answering compiler issues generated by them.
Oh, that's fair. Any other questions? All right, well, that was my lightning talk. Thank you.